Welcome to my channel, where your adventure into the future starts right now. Step into a vibrant universe filled with groundbreaking technology, breathtaking alien landscapes, and exhilarating sci-fi narratives that challenge your imagination. From daring explorations of distant galaxies to haunting journeys through dystopian societies, we uncover the most captivating stories and innovative ideas that will shape the world of tomorrow. Subscribe today and join us on an incredible intergalactic voyage that promises to inspire and thrill. Humanity's expansion into the stars was marked by both the promise of progress and the looming shadow of ecological responsibility. As humankind reached out to distant planets and moons, the dream of creating habitable worlds beyond Earth was tempered by the realization that the ecosystems of these alien worlds would not naturally support human life. Earth, with its vibrant ecological tapestry, lush forests, rolling grasslands, arid deserts, sprawling oceans, and towering mountain ranges, had taken billions of years to evolve. The complexity and interconnectedness of its ecosystems were not easily replicated. Yet humanity had already proven its ingenuity in countless ways, and as the stars beckoned, it became clear that they would not be leaving their planet's biosphere behind. In the early stages of galactic colonization, the focus was on survival, terraforming barren planets to create human environments that could sustain life. On Mars, the first successful steps were taken: vast domes, pressurized atmospheres, and the introduction of imported water from asteroids. The early efforts focused on mimicking Earth's atmosphere and creating self-contained biospheres where crops could be grown, air could be breathed, and water could be recycled. Yet, these artificial ecosystems felt sterile. Humanity was still trying to recreate what was lost, and that which was lost was far more complex than anyone could have imagined. The problem was not just about finding a way to survive, but about what humans were taking with them as they colonized the stars. The concept of ecological diversity, Earth's vast web of life, was not something that could be replicated easily on these alien worlds. Each planet had its own unique conditions, its own soil, atmosphere, gravity, and chemical composition. Even if humans could construct artificial environments for themselves, the richness of life, flora and fauna, microorganisms, and complex ecosystems was something that could not simply be recreated on demand. It was then that a revolutionary idea began to take root. Rather than attempting to recreate Earth's environments from scratch, why not bring Earth's ecological diversity with them? What if humanity could take the very essence of Earth's life, its seeds, its microbes, its animals, and introduce it to the barren worlds they sought to colonize? Instead of merely creating artificial biomes, humans would become stewards of the ecosystems that once flourished on their home planet. The idea of ecological transference was born, a bold plan to take Earth's ecological diversity to the stars. The logistics of such an endeavor were daunting. How could humans possibly transport Earth's fragile ecosystems across the void of space? The first step was to identify the elements of Earth's ecology that were essential to the broader goal. They weren't just interested in taking crops and domesticated animals. No, the vision was far broader. If humanity wanted to bring life to barren worlds, they would need to transport not only plants and animals, but also the microscopic life, bacteria, fungi, and other microorganisms that played crucial roles in maintaining ecosystems. Earth's diverse microbiomes were integral to soil health, water purification, plant growth, and disease resistance. Without them, even the most carefully constructed environments would fail to thrive. The solution lay in advanced bioengineering. Researchers developed techniques to encapsulate and preserve a vast array of biological material in a form that could withstand the rigors of space travel. Using genetic engineering, they were able to create synthetic seeds containing the genetic code of Earth's plants, trees, and flowers. These seeds could survive the harsh conditions of space travel and be planted in carefully prepared environments on distant worlds. Similarly, a variety of animals ranging from insects to larger vertebrates were carefully bred in captivity, with their genetics cataloged and preserved. The challenge was not just preserving life in its most recognizable form, but ensuring that all the underlying biological processes such as pollination, nutrient cycling, and symbiosis would function once these organisms were introduced to new planets. In addition to terrestrial life, the oceans of Earth held another challenge. Humanity's oceans were home to an untold diversity of life: coral reefs, fish, marine mammals, and microorganisms that formed the foundation of marine ecosystems. Recreating Earth's oceans on distant worlds seemed a monumental task, but it was not beyond reach. Oceanic ecosystems could be replicated by introducing aquatic species to specially designed aquatic biomes in closed water bodies with carefully balanced salinity, temperature, and pH. The challenge was to ensure that these ecosystems could be self-sustaining. Coral reefs, for example, required highly specific conditions to thrive, and the animals that relied on them needed a complex interplay of nutrients and food webs to survive. Still, humanity was determined. Perhaps the most revolutionary aspect of this idea was the inclusion of Earth's microbial life. Bacteria, fungi, and viruses were often seen as nuisances or dangers in controlled environments, but these microscopic organisms were, in fact, the engines of life on Earth. They were the unseen workers that broke down organic matter, fixed nitrogen in the soil, and helped plants absorb nutrients. Without them, plants couldn't grow. Soil would become barren. Humanity's solution was to create bioengineered microbial mats, carefully designed communities of microorganisms that could be introduced to alien soil to kickstart the processes of life. These mats were a combination of nitrogen-fixing bacteria, decomposers, and symbiotic fungi that would interact with the soil and gradually build the foundation for a thriving ecosystem. The first test of this ecological transference took place on a barren planet known as Kepler-62f, a distant world that had been identified as a candidate for colonization. Kepler-62f was a rocky planet located in the habitable zone of its star, but it had no native life. The planet was cold, arid, and devoid of the basic conditions needed to sustain life as humans knew it. But it had the right atmosphere, a stable climate, and enough water locked in the form of ice beneath its surface to make it a prime candidate for ecological experimentation. The first step in the project was to launch a massive terraforming initiative. Rather than using traditional methods, which had relied on large-scale atmospheric engineering, this new approach focused on the introduction of biological agents, microorganisms that could alter the chemical composition of the atmosphere. Specially engineered cyanobacteria, capable of photosynthesis, were introduced into the planet's soil and ice. These microbes slowly began to release oxygen into the atmosphere and fix nitrogen in the soil, transforming an inhospitable environment into something more suitable for life. Once the atmosphere had been enriched with oxygen and the soil began to support plant life, the next step was to introduce larger forms of life. Trees, grasses, and shrubs were planted using the genetically engineered seeds that had been created. These plants were designed not only to thrive in the new environment, but also to foster the development of a balanced ecosystem. The trees would provide shelter for animals, while the grasses would stabilize the soil. With the introduction of plants, the next phase of the project began, the introduction of animals. The animals selected for this first phase were small, hardy creatures that could survive in the controlled environments of Kepler-62f. Insects, birds, and rodents were released into the growing forests, and the complex webs of interaction began to form. Pollinators began to fertilize plants, herbivores fed on the grasses and shrubs, and carnivores maintained the balance by preying on the herbivores. Slowly, but surely, the planet began to come to life. The success of Kepler-62f opened the door to further colonization efforts, as other barren planets across the galaxy were selected for ecological transference. Each new world required its own unique approach, as conditions varied widely. Some planets had extreme temperatures, others had higher or lower gravity, and still others had differing atmospheric compositions. But the basic principles remained the same: humanity would bring Earth's ecological diversity to the stars. The introduction of Earth's ecosystems to new worlds had profound effects not just on the colonized planets, but on the way humans viewed their relationship with the universe. Initially, some feared that humanity's attempt to create Earth-like ecosystems would somehow overwhelm or destroy the native ecosystems of alien worlds. There were concerns that humanity, in its pursuit of ecological diversity, might inadvertently introduce invasive species that would disrupt the balance of life on distant planets. To mitigate these risks, strict protocols were established, and every new colonization effort was accompanied by careful environmental studies to ensure that Earth's life forms would not harm native life. Over time, these fears proved largely unfounded. The ecosystems that humans introduced were carefully tailored to the specific needs of each planet. The advanced bioengineering technologies humanity had developed allowed for a level of precision in ecological design that ensured that each world received the right combination of species, plants, and microorganisms. With the right balance, Earth's life forms began to thrive on these new worlds, creating vibrant, self-sustaining ecosystems that became the foundation of human colonies. As the years passed, humanity's efforts to bring Earth's ecological diversity to barren planets became a central part of their identity as a spacefaring species. The concept of stewardship became embedded in human culture as people across the galaxy took pride in the restoration and preservation of life on these newly colonized worlds. The successful transplantation of Earth's ecosystems was not just a technological triumph, it was a testament to humanity's deep connection to their home planet and their responsibility to the future of life in the universe. In the end, humanity's efforts to bring Earth's ecological diversity to barren worlds became one of the defining achievements of the space age. It marked the beginning of a new chapter in human history, one where humanity's technological prowess was matched by their commitment to ecological responsibility, where the preservation and nurturing of life on distant worlds became a central part of their purpose in the cosmos. As the stars beckoned, humanity no longer saw themselves as conquerors of new worlds, but as stewards of life, working to bring balance and diversity to the universe one planet at a time.